Sweater weather try.
All right, let's get going here.
I've been wanting to try their vampire weather.
So it looks like I'm going to have to make the class harder. No, I'm kidding. I'm kidding.
Wait, what'd you say?
What?
Pardon?
Nothing. I didn't say anything. So these are the grades for this exam. We had 12 A's, 4 B's, 1 C, 3 D's, 2 F's. So class average was an 85, standard deviation was 16, so that's really good. This is, yeah, it's about par for the course. So, yeah, but this is really good. So the exam, I think, went well. I think the review helped get everybody kind of squared away. The material's going to get harder, all right? So, I mean, it is going to get harder, so just be prepared for that. I'm going to give you your test back, but I'm going to do it at the end of class. All right? So, sorry, but you'll have to wait. You should know your grade. You should at least know your grade from Canvas. Any questions? I'll address any questions you have on the exam next class. All right, if you have anything specific you want to talk about. All right, so it was good. Light. All right, so we are going to start chapter 8 today. And given the results on that exam, I'm feeling pretty good about us leading into this chapter. Chapter 8. So analytic geometry is the title of this chapter. And the first section out of this chapter, 8.1, is titled The Inverse Sine, Cosine, and Tangent Functions. Inverse sine, cosine, oh my gosh, come on, Robert. Sine, cosine, and tangent functions. So what I'm going to do is I'm going to kind of wrap up. There was a section like chapter 6, section 6 or something about inverse functions, one-to-one functions. I'm actually going to like cover that as I do 8.1. So we're going to start with a quick review of what is an inverse function, what is a one-to-one function. Once we do that, then I'll get into this, all right? Now this should be a college algebra topic. So this is where we are, all right? This is what we're doing today. But I'm going to put here recall from Math 1414, college algebra, all right? The idea of an inverse function. Inverse functions. So the concept of an inverse function is pretty simple. The idea is that if you start with our classic picture of some function f that has some domain, those are numbers that you plug in, right? They go through the function, they come out on this side, you've got the range of the function, right? That's our standard picture of some function f. Well, the inverse function is a function that sends everything over here back to where it came from. Right? So it's some function that goes back this way, f, and we use a little -1 for the notation to let everyone know that we are talking about an inverse function. Does this look familiar from 1414? Yes? So, an example. Let's say we start with the function f of x equals 3x plus 4. Right? That's a linear function from college algebra. Very simple function, right? Is there a function that basically undoes that function? Does it have an inverse, right? So we can look at it a couple of ways. First way we look at it is visually. If we graph that function, we know it's a line, right? Has a y-intercept of 4. Has a slope of 3, right? Something like that, right? That's the graph of that function f. The inverse function should undo this one. So, what do we mean? It means every input that went in to this function and comes out, the inverse function should take that output back to where the input was. So how do we look? Does anyone remember from college algebra how you can look at the graph of a function and tell whether or not it even has an inverse? There's something you do. You run a quick check on it. Anyone remember what it is? Does it? What? I heard it.
Isn't that horizontal line?
Horizontal line test. Okay, so do y'all remember the vertical line test? The vertical line test, you take a vertical line and you draw it. Any vertical line, if you ever hit the graph more than once, it's not a function, right? So the vertical line test, I'll put it over here. Vertical line test is a test for a function. So you run that test, right? You're running the vertical line test to see whether or not you have a function. So I thought there was a ruler in here, a big old yardstick. No, I don't see anything. I'll just use this. So if I draw any vertical line, right? If I ever hit the graph more than one time, it's not a function. This is a function, right? Now to see if it has an inverse, we run what's called the horizontal line test. I'm not writing this because this is a review, okay? So if I need to go into any more detail, please stop me and say, can you please clarify that? The horizontal line test, you do the same thing, but you draw horizontal lines. If you ever hit more than one time, right, then it doesn't have an inverse. So this is a test for an inverse, all right? Tells you whether or not you have one. Okay, that looks familiar, yeah? So this is a function, yes? 3x plus 4 is a function, and it has an inverse, yeah? Does anyone remember how you can find the actual inverse function? Say again? Yeah, so there's something you have to do with this algebraically, right? So let's see if you remember this from college algebra. How to find f inverse, right? If it exists. If it exists. So if it exists, if you run the horizontal line test and it passes, then it has an inverse. So if the inverse exists, how do we find it? What you do is you take the original function, you rewrite it, you replace the f of x with y. Tell me when this starts to look familiar to you. You switch x and y. Everywhere you see an x, you put a y. Everywhere you see a y, you put an x. So I put x here equals 3y plus 4. So what did I do there? I switch x and y, right? I switch them. And then what do? Solve for y. Get y by itself. So here to get y by itself, I would subtract 4 on both sides. And then I would divide both sides by 3. I'm going to put this up here. I get x minus 4 over 3 equals y. So I have solved for y, right? This should be your inverse function. So I'm going to put it in blue. My inverse function, f inverse of x, should be x minus 4 over 3. All right? So I said I want us to look at this two different ways. The first way is visually, right? Visually, if I draw something, you should be able to run the vertical and horizontal line test to see whether or not you have a function and whether or not it has an inverse. If it does have an inverse, algebraically to solve for it, you have to do this. Switch the x and y, solve for y. Right? Let's just check that that is the inverse, that it does what it's supposed to do. So I'd like to take some values of x and just see what happens. So let's say I take, for this particular function, let's say I take the number 4, okay, and plug it into this function f. Where does f take the number 4? Plug 4 into f, and where does it come, where does it get sent? $16. Y'all okay? Yeah, 16. 3 times 4, right? 12 plus 4, 16. Right? So it gets sent over to 16. That's what f does to the number 4. Now, the inverse function, right? The inverse function, f inverse, should send that 16 back to 4. That's what it should do, right? Does it? Plug 16 into the inverse. So plug in 16 right here. 16 take away 4 is 12 divided by 3 is 4. See? It got sent back. So that's what inverses do, right? They send numbers back to where they came from. All right. Good? All right. So today what we're talking about is the inverse sine function, the inverse cosine function, the inverse tangent function. So the sine function, what does the sine function take in? What do you plug into the sine function? You give it something. What is sine of
An angle.
an angle, right? You usually give a sine function an angle, right? And it spits back some number, right? And that number, remember that number was always between -1 and 1 with the sine function? And same with cosine. We had like the numbers you can plug in, the numbers that come out, right? But the main thing that I want to point out is that for all the trig functions that we've done, all 6 of them, right? You feed it an angle and it spits out a number, right? Angle in, number out. We want to see, is there a function that takes that number, sends it back to the angle, right? That's what we want to see. So we're going to start with the sine function. So this is the big question here to start. Does f of x equal sine x have an inverse? Now, I think the obvious answer is yes, because we wouldn't be talking about it if it didn't, right? But let's talk about the graph first. Let's look at the graph of sine of x. What does sine x look like? If I ask you to graph it, everyone should be very comfortable at this point with the idea that the graph of sine looks like that, right? It goes forever in this direction, and it goes backwards forever, doesn't it? We know, all these little things about it, right? Amplitude is 1. We know 1 period of this sine function is 2 pi, and so on and so forth, right? Does it have an inverse? Does it pass the vertical line test? So it is a function, yes. Does it pass the horizontal line test? No, it does not, right? If I draw a horizontal line, I'm going to hit it infinitely many times, aren't I? Imagine a horizontal line going through there. So this does not have an inverse, all right? Not the way I have it drawn right now. There is no inverse. I'll give you an example, okay, to try and get you to see if you understand this or not. Right now, imagine that I give you this function f. Here's the sine function, okay, sine of x. I'm going to feed it an angle, all right? But I'm not going to tell you what it is. Question mark. And now I'm going to tell you that what comes out over here is root 2 over 2. So can you tell me what the angle is? So sine of what angle is root 2 over 2? I heard it. 45 degrees? You're getting that from the unit circle, aren't you? Right? What is that really saying? Sine, right, of something equals root 2 over 2. Right? That's what that's saying. And someone said 45 degrees. You can go to the unit circle. Sine is the y coordinate, right? And we're asking where is it root 2 over 2? Someone said 45 degrees. I agree. That would be an answer, wouldn't it? Root 2 over 2. But is it the only answer? No. You could have said that angle as well, right? But aren't there an infinite number of solutions to this? We talk about that. Like you could go to pi over 4, or you could go all the way back around, couldn't you? Or twice. So remember on the test you had answers that were like, you know, pi over 2 plus pi k or something like that, right? There is an infinite number of answers. And that is a major problem, because if I'm trying to have an inverse function send it back, right? I need to know where to send it to. I can't send it to an infinite number of places. It has to go back to one place. That make sense to you? I have to send it exactly back. So as the sine function appears here, there's no inverse. So what we have to do is we have to what we call restrict its domain. We have to cut the picture in a way that there's only one possible answer going backwards. And we all, as human beings, right, thinking human beings, we had to all agree where to cut it, all right? We could have cut it in a lot of different places, but what we agreed to is this, all right? So does everyone understand the dilemma right now? The horizontal line test fails, which means we have an infinite number of places to go back to here. So what we decided is this. So since it fails the horizontal line test, we agree to restrict the domain as follows. So what we're going to do is we're going to draw the sine function again, all right? But when I start to draw it, how does it go? It goes up like this. I'm going to stop when I get to the top of that hump. Right there, that's pi over 2, right? That happens at pi over 2. This is 1 up there, right? And then I'm going to go backwards to here and stop there. And that is negative pi over 2. And if I just look at that little piece of the sine function, do you agree that it passes both the vertical and horizontal now? Yes? And more than that, every value between -1 and 1 is achieved, right? There's at some angle, negative pi over 2, you're at -1, and every angle between here and here, you have all possible y values come out, right? This is what we all agreed would be our domain restriction for sine. If we restrict it this way, then we can define the inverse function. Now, we didn't have to do this, all right? We could have agreed as humans, right? We could have agreed to this. We could have said, all right, it goes backwards, right, like this. It goes forward like that. We agreed to this, right? We said, all right, let's do that piece, okay? That's the one we chose. But there's nothing wrong. We could have, if we wanted to, we could have done this one right here and had our domain restriction just in that region. Does that make sense? We could have done that. But that's not, this is what we did, okay? Can't change it now. We've all agreed to it, all right? It's hard to get anyone to agree to anything these days, right? So it's amazing we ever agreed on this, right? But we did. Okay, so now, let me ask you this question again. What is this? If I restrict the domain, what's the only answer? Pi over 4. Let's see why, though, okay? The way I'm going to do this, remember what this question is asking us. It's saying, sine of what angle, right, is root 2 over 2, right? That's this. Generally speaking, there's an infinite number of answers here. However, I am now restricting our domain between negative pi over 2 and pi over 2. So when you go to the unit circle and you start thinking about where your y-coordinate is this, right? You're only allowed to look between, that's pi over 2, right? That's negative pi over 2. Yes? You're only allowed to look between here and here. So you're not allowed to look here. And so in the first quadrant and the fourth quadrant, there's only one place that the y-coordinate is root 2 over 2, and that's here. Right? So that is pi over 4. So the answer to this would be pi over 4. We good? You understand? See, we had to figure out a way to send it back to only one place. So we had to do this restriction. Let's see if you really get this. Let me give you another one, okay? How about this? How about, see if I can trick you. Question mark gets sent to -1. If you know right away, don't just hold on. I want everyone to get a chance to think about this. So we're saying sine of what angle, right? Sine of what angle gives us -1. So you're thinking, where on the unit circle, right, is my y-coordinate -1? And you immediately think 3 pi over 2. That's wrong. Why is it wrong? I'm not saying you, everyone. Okay, some people didn't think that. But why would 3 pi over 2 be wrong? Well, that means your angle would have to go all the way around here, right? And come back down like that. You're not allowed to go that way. You can only go up and down. That's all you can go, between negative pi over 2 and pi over 2. So we need to get down here, right? So we need to rotate this way. And now you're straight down. So what's your answer? Negative pi over 2. Understand? Understand? So this got to go this way, negative pi over 2. And now you're down here, your y-coordinate's -1. So this is negative pi over 2. Yeah? I'll give you one more. I'll give you this one to think about. I'm out of room, so I'll just squeeze it in here. Question mark gets sent over to -1/2. Raise your hand if you think you have it. You got it? I just want to see when people think they have it. Yeah? Yeah, okay. Got about half of you. You can put it down. Raise it again. Put it down. One more time. Down. Thank you. So this question is asking us, right, where on the unit circle is your y-coordinate -1/2, right? Which is, you see how you got to know the unit circle, right? Like if you don't know the unit circle, I told you it would be this way, right? You're just torturing yourself if you don't learn it. It's here, right? Isn't that where it is? What angle is that? Negative pi over 6, right? Because you have to know that up a little bit, right, would have been +1/2. That's pi over 6. So we're rotating this way now, negative pi over 6. Okay. Yeah? All right, so now some notation. I don't want to have to write this down like question mark goes over here, right? I need to somehow be able to ask you the same question in a nice compact way. So we have some new notation to represent this function, right? So if notation, if f of x equals the sine function, sine x, and we restrict x between negative pi over 2 and pi over 2. All right, so if we start with the function, the sine function, right, and we do this appropriate cutting of the domain, which means we only look between here and here, right? If we do that, if we start there, then the inverse function, which we use that little -1 there, right, is written this way. Sine with a little -1 right there, and then you can put parentheses around the x. You don't have to put parentheses around the x, but it doesn't hurt to have them. That is the new notation for the inverse of the sine function. And that right there, we call, there's two different ways you can refer to this. You can call this the inverse sine, or it's also called the arc sine function. All right, so that's the notation we use to represent the inverse of the sine function. Now, unfortunately, there's a second notation, and you're free to use either one. Or, okay, you can write this. F inverse of x equals arc sine x. That's the way it's written. Arc sine of x. This and this are the exact same notations. I mean, they're not the same notation. They mean the same thing, but there's two different ways to write the same function. So you know the problem I just gave you a minute ago where we had f of x was 3x plus 4, and then I said, how do we find the inverse? We replace this with y, we switch the x and y, we solve, right? There's no way to do that with sine x. You can't do it that way, algebraically. You can't replace this with y, switch the x and y, and solve for y. You can't do it, okay? You have to understand what the function is doing. That's all it's about. Let's do some examples. We've already done some, but now I'm going to use the proper notation. What is this? And let me call on somebody. We haven't done this in a while. It was fun, right? Let's see. Yeah, it's been a while. Wow. Okay. Brandon?
Yes.
How you doing, Brandon?
Pretty good.
Good? You think you feel good about this?
Sure.
Yeah? So can you tell me, like in words, what this is saying or asking?
Well, you're plugging in where it's y and telling the function or the inverse function to give you your angle.
Exactly. You want an angle.
So that's going to give you the angle where the y-coordinate is 1.
Exactly. On the unit circle, it's the angle where the y-coordinate is 1, right? Perfect. Which is where?
Pi over 2.
Straight up. Now, is pi over 2 legitimate here? Like, is that okay? Because remember, we have a domain restriction, right? We have to always be between negative pi over 2 and pi over 2, right? So pi over 2 is valid, yes? Pi over 2, straight up? Good. Pi over 2. We're done. What you can't do is tell me that the answer is negative 3 pi over 2. That's not correct, right? You can't go around this way, negative 3 pi over 2, and stop there. That's not allowed, right? You can only go straight up. How about this one? How about inverse sine of 0? Daza? You following? Okay. So in words, tell me what this is asking. Yep, it's saying at what angle, right, is the sine function 0? So in terms of our unit circle, it's asking, this is really asking where the what is 0? The y coordinate, right? Which is, where is it? pi is back here, right? The y-coordinate is 0 here. Everyone agree? The y-coordinate is 0 there? But you can't go there. You're not allowed, right? You're not allowed over here. Is there anywhere else where the y-coordinate is 0? At 2 pi, right? But hold on, you went all the way around. You're not allowed to, right? So what's that angle pointed out that way? Just don't go anywhere. Don't go turn. Just 0. Exactly, right? It's the angle 0. That's a weird problem because the angle is also the answer, right? Like sine of 0, 0. If you use the 0 angle, you're going to get a y-coordinate of 0. Good. One more. Different notation. Arc sine. I mean, I don't know. Negative root 3 over 2? Chris. No?
What's up?
What's up? Are you okay with this?
Yeah. I think it's negative 60 degrees.
Negative 60 degrees. So you're looking on the unit circle for where your y-coordinate is negative root 3 over 2, right? So that's down here.
Yeah.
So you got like, this is the 1/3 mark, the quarter. These are your like important angles, right?
Yeah.
And so you're saying down here, your y-coordinate is negative root 3 over 2. Y'all agree? So we're at the right location, and then you said that's negative what?
Negative 60.
Negative 60 degrees. That would be okay.
Negative pi over 3.
Negative 60 degrees would be okay. You just need to make sure you put 60 degrees, or you put negative pi over 3. I prefer you all start working in radians because in Cal 1 and 2, we're almost exclusively in radians. So I know degrees are just like, we love degrees because they're easy to remember, but, you know, yeah. Okay, we good? Is this making sense? All right, let's try another one.
What about Cal 3?
What about it?
Radians too?
Yeah, pretty much the whole, I mean, we kind of just do, we don't do away with it, but degrees just aren't preferred, I guess. They're just not used as much. Yeah. What's that?
Like, is there a reason for this, like, rating?
It's a little hard to explain, but it's because if you go back and remember the definition of what a radian is, I almost asked this as a bonus question. I was going to draw this picture, and I was going to label this R, and I was going to label this R, this right here, and I was going to ask you what theta is. I was going to ask you to find theta. I was going to see if anyone knew what theta was. Does anyone know what it is?
1 radian.
1 radian.